You wish I had a better microphone? I'm using the built-in mic because I have no equipment. So, yeah. Good old Ann. Scientific notation, 5.5 times 10 to the 4. So the rule for scientific notation, do you just count zeros? No. You count how many spots the decimal point is over. And I hope you can do a smaller number like that almost in your head even without counting. I don't know if I would do that one in my head. I'd have to physically count. But I can do this next one in my head as well. It's going to be 4.2 times 10 to the negative 2. I'm going to be fussy for both of these, all or nothing. Okay? Just make sure it gets in the garbage when you're done or whatever. Clean up after yourself. 3.64 times 10 to the negative, this one I have to count, 1, 2, 3, 4, is it negative 5? Okay. 1.236 times 10 to the 1, 2, 3, 4, 5, 6, I'm pretty sure it's 7, all or nothing. 1 mark for each of those, so that little section's out of 4. Perform the following operations. Now, there are 2 Sig Fig rules. One for multiplying, dividing, a little easier. One for adding and subtracting, a little trickier. Multiplying and dividing, I count 2 Sig Figs, 2 Sig Figs. I'm going to go to 2 Sig Figs. I don't round off on my calculator. I got 2.556. I know that E on my calculator is an abbreviation for times 10 to the negative 10. Now, 2 Sig Figs. 1, 2. Is that 5 going to stay a 5 or become a 6? 2.6 times 10 to the negative 10. I'm going to be fussy, all or nothing. 3 Sig Figs, 2 Sig Figs. I'm going to go to 2 Sig Figs. 1.42 scientific notation, negative 5, divided by 4.3 scientific notation, negative 15. Oh, how many Sig Figs? So I'm going to round to there. Is the 3 going to stay a 3 or become a 4? But I can't just go 3.3 because the answer wasn't 3.3. It was 3.3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes? 9, yeah? Yeah. All or nothing. Adding and subtracting scientific notation with Sig Figs, I need to unscientific notation them. So I'm going to write this as 0.006. That's 6.0. Oh, sorry. I have to put a 0 there because there's a 0 there. And I'm going to write this as 0.00035. I'm going to round to this decimal place, which is the 4th decimal place. So 6.0 scientific notation, negative 3, plus 3.5 scientific notation, negative 4. So I get that, and I'm going to round to that decimal place right there. Is that 3 going to stay a 3 or become a 4? Yeah, so it's going to be 0.006. And now in scientific notation, 6.4 times 10 to the negative 3. Convert, 1 mark each. 3 seconds, I want seconds to cancel. I want milliseconds left behind. Milli is 10 to the negative 3. Where does the 10 to the negative 3 go? Top or, doesn't matter, top or bottom. It always goes where you don't have that small lowercase letter metric prefix. Oh, and since it's on the bottom, what am I going to do with that 10 to the negative 3? Multiply or divide? Again, I recognize this conversion chain method is tricky to wrap your brain around. Evan, I'm telling you, once you wrap your brain around it, it bails you out of a lot. I was saying to my Physics 12s earlier today, I took Chem 11 in grade 12, and I got an A without knowing any of the chemistry. I would just look at the units of the final answer and figure out how to use the numbers that I was given to get that as an answer and match the units. Worked great. So it's going to be 3 divided by 10 to the negative 3. Do you get 3,000? Did I say you had to write in scientific notation? So if you didn't put units, I'm taking a half mark off. I told you units matter. Remember that poor guy on Verizon? If you wrote it in scientific notation, it would be 3 times 10 to the third. And if you wrote that, that's fine, but still milliseconds. I'm going to do my work for B right here. So there's my work for A. B, 25 kilograms. I want kilograms to cancel. Grams goes on top. Kilo is 10 to the third. Now I want grams to cancel. Milligrams on top. 10 to the negative 3. So it's going to be 25 times 10 to the third divided by 10 to the negative 3. I get a 25 and 6 zeros. And if you wrote that, fine. I think here it's going to be shorter for me to write it in scientific notation. And since the instructions gave me a choice, I'm going to choose to be naturally lazy. And I'm going to go 2.5 times 10 to the 7th. Milligrams. No units, half mark off. So you either wrote a 2 and a 5 and 6 zeros, or 2.5 times 10 to the 7th. C, 1 year into seconds. 1 year times days, 365 times hour. I want days to cancel, so I know the D goes there. Hours, 24 hours is 1 day. I have memorized that there is 3,600 seconds in 1 hour. Otherwise, I would go, I think, 60 minutes and then 60 seconds. Also, I'm running out of room to write, so I had to cheat a little bit. 365. Oh, they're all on top. So times 24 times 3,600. You get 315360000. I could write this in scientific notation, but I'm going to have to write 5 numbers no matter what. And it's less work than just to write 3 zeros instead of going times 10 to this. I'm going to write this one out. 31536 zeros. 31536 1 2 3 zeros. Seconds, or 3.1536 times 10 to the 1, 2, 3, 4, 5, 6, 7. Any questions on that? If you want to, you can give yourself a little score out of 4, 5, 6, 7, 8, 9. I think the front page. Oh, it is out of 10. Geez, I put that there. I usually do that. Turn the page. 1.25. Oh. 0.25 times 0.50. I typed the 0. Will the 0 make a difference in my calculation? So I'm probably in the next couple of weeks going to stop putting those zeros in because I'm lazy. I get 3 sig figs, 2 sig figs. I'm going to go to 2 sig figs, 0.63. All or nothing. 3 sig figs. 4 sig figs. I'm going to go to 3 sig figs. 51.3 times 3.94. I'm not going to bother typing the 0. What did I say? 3 sig figs. It's worth writing that down because then if you forget later, you can jog your memory. 202. You could put a decimal there. That won't change anything, but you can't put a decimal and a 0 after the decimal. And I'm lazy. I wouldn't bother putting the decimal there. 3 sig figs, 4 sig figs. I'm going to go to 3 sig figs. Zero, 0, 856. 3 sig figs. This 0 right here, is it going to stay a 0 or become a 1? So it's going to be 511, but then I have to fill in the remaining zeros. Or you could have written 5.11 times 10 to the fifth, Mr. Dueck? Yeah. The advantage with scientific notation is you can tell at a glance that this is 3 sig figs. It's easier to count the sig figs. Adding, subtracting. I know this is 5 sig figs. This is 5 sig figs. I'm not going to use that. I'm going to use decimal places. Jackson, this is 3 decimal places. This is 5 decimal places. I'm going to go to 3 decimal places. 38.002 plus 0.12378. How many decimal places? Right to there. Is that 5 going to stay a 5 or become a 6? So 38.126, all or nothing. Anybody write that in scientific notation? 3.8126 times 10 to the 1? Two decimal places, 1 decimal place. I know it's 5 sig figs and 3 sig figs. I don't care about that. I care about decimal places. 512.06, take away 65.2. 1 decimal place. That 8 is going to become a 9. 446.9. $48 parrots times 5 parrots, 1 zebra times 1 zebra, 8 monkeys times 6 monkeys, 1 gorilla times 5 gorillas, 2. And I think I told you I always make my lowercase l's cursive, otherwise they look like 1s. You can see if I didn't do that, I would probably type 21 on my calculator because I'm stupid that way. So good habits to pick up. Multiply by the top, divide by the bottom. 48 times 8 times 2 divided by 5 divided by 6 divided by 5. Do you get 5.12? Yeah. So how would I, units, lions. How would I mark this if you got that in any method? 3 out of 3? If you wrote down what they gave you, if you got this wrong, but you wrote down 48p, that gets you 1 mark. If you tried building a chain, even if you did it wrong, that gets you 2 out of 3. I really am less concerned about the final answer, Sam. I'm much more concerned about the method. And it's write down what they gave you and build a chain. Okay? Can you give yourself a lovely score out of 18, please? Last day we said in physics everything is either a scalar or a vector. Scalars have magnitude only. Vectors have magnitude and direction. And that's going to become very important as the year progresses. We talked a little bit about how we write vectors. We put an arrow over something to show that it's a vector. We talked about the difference between distance and displacement. And that you are going to have to know, but I think that you'll memorize as you're doing the homework. So I don't think you need to go crazy out of your way. Don't write this down yet, Logan. I'm going real quick. We talked a little bit how to write position. We said we could use words like to the left and to the right, but we decided negative and positive were much more convenient nomenclature. That's a fancy word for naming and labeling methods. Really what I wanted to get to is here. And you can put a mental star next to this. We are going to be talking an awful lot about the difference between speed and velocity. Okay. Average speed. Your average speed is defined as the change in distance over the change in time. That's a little triangle, except it's not called a triangle. For a candy, does anybody know in science and in math what we call that little triangle symbol? Sorry? No. Okay. This is a Greek letter. delta. You'll hear me use that. That is one. Again, you don't need to memorize that. You just will, because I'll use it fairly often. You'll hear me talk about delta V or delta whatever. Okay. And in English, in science, that actually means change in. So if I read that to you, I would say average speed is change in distance over change in time. As an equation, our symbol for speed is not S, it's V, and that's because our symbol for velocity, which is the vector, is V. So if I wanted velocity, I would do that, but this is the scalar speed, the pairing that goes with velocity. And it's d over t. Is that on your formula sheet? First row or second row, I think, on the front. Did I put a triangle in front of the T? I did? Okay. Units. It is really, really, really worth memorizing what units go with what. Now, you won't need to go out of your way, Ben, to do that, but you are going to hear me say one of my problem-solving strategies, if I'm looking at a question, I'm not necessarily looking for numbers, I'm looking for the units, because that tells me, oh, meters per second squared, that's an acceleration, newtons, that's a force, kilogram meters per second, that's a momentum. You'll memorize these units, and it cuts down on the rest of your thinking very much. So what are the units here? What do I measure distance in? Meters. Per. What do I measure time in? No, not in physics. So the units are kind of hidden in the question. It's meters per second. Is speed a scalar or a vector? Before you turn the page, here's what I'm getting at. Let's suppose that you travel to Vancouver, and let's make up some nice round numbers. Let's suppose that that Vancouver is 88,000 meters. Sorry, got to get this right, Mr. Dueck. 80,000 meters away, 80 kilometers. If you knew how many seconds it took you, you would divide those two numbers, and that's your average speed. You do this all the time with kilometers per hour. Another way to measure speed, not the SI physics unit for speed, but the car speedometer unit for speed, is kilometers per hour. You say Vancouver is 80 kilometers from here, and it took me an hour to get there, so I went 80 kilometers per hour. Or it took me 45 minutes to get there. You would convert 45 minutes to 3/4 of an hour, and we do this all the time kind of intuitively. Average velocity is that. Mr. Dueck, isn't that just what you wrote on the previous page? What's the big, very subtle, but very important difference? The vector sign. Okay. What is a D with a vector bar above it, not distance? Okay, average velocity is your displacement over time. Where, once again, that triangle, which we call a delta, is the change in. So as an equation, velocity equals displacement over time. I don't know, did I also put that equation on there? Or did I put only the vector equation on your formula sheet and just assume you could derive the scalar one from it? Or did I put both? I have a feeling I wouldn't have put both because the sheet was getting cluttered. Which one, the vector one or the scalar one? The scalar one, and so the vector one is kind of hidden in there. Units, what do I measure displacement in? Per. So the units for velocity and for speed are the same, but velocity, vector or scalar? Vector. Last day, we looked at a bug. Okay? It says, if the bug's trip in example 1 took 30 seconds. So I'm going to go back. You can stay where you are. But way back here, here was our numbers. The bug, you can jot just down on your page right now. Off in the margin, could you jot down d equals 14 and d vector, so distance equals 14 and displacement equals -6? Once you've all written that down, I'm going to come back to this. Okay. So what's the bug's average speed in meters per second? Well, it's going to be the distance over the time. Now, I've already gotten a tiny bit sloppy. I'm going to introduce you to some conventions. Time, which we symbolize with the letter T, is always a change in. And because it's always a change in, there's no way to measure time without starting and stopping a stopwatch. It's how you measure time. We get lazy in physics, and we often stop writing the delta in front of it. So you may notice that I often just put a T because there's an implied delta T for time. I notice I did it right down here, for example. I didn't put the triangle in front of it. And I noticed without thinking about it, I did it right here too. What was the distance? What did I say? Was it 14? Divided by 30? Technically, I should only go to 1 sig fig because 30 is a 0. Let's go to 3 sig figs just so we have some interesting answers. 14 divided by 30. I might be able to do that in my head. It's going to be 7 over 15. Eee. It's a yucky decimal to do math with. It's going to be the same as 70 divided by 15, divided by 5, divided by 5. Oh, no, I'm getting yucky numbers. Do you get 0.46 repeating? So if I go to 3 sig figs, 0.467, yes? Meters per second. What was the bug's average velocity? What was the displacement? -6? And divided by 30. Am I going to get a positive or a negative answer? What does that mean as a direction? Left or west? But I'm just going to write -6 divided by 30. That I can do in my head. 0.2, yes? Double checking. Okay. If I wanted to go to 3 sig figs, I would go 0.200. You know what? It worked. I'm not going to be that fussy. Units. Units. Meters per second. I'm going to introduce you to maybe the single best gift I'm going to give you this year. The ability to cut down on your memorizing by rewriting equations in your head. We call this formula manipulation. I'm going to break you from your reliance on numbers, and I'm going to move you to the wonderful world of doing algebra. Here is the equation that I gave you. Average velocity is displacement over time. How many different variables are there in that equation? How many different equations is that actually then? Now you can memorize all 3, or I can teach you how you can derive each one of them from this single equation. We're going to do that. How would I get the d by itself if I wanted to get an equation for displacement? Well, let's write down the original equation here. I want to get the d by itself. What else is on the same side as the d? T. What's the t doing? Adding, multiplying, dividing, or subtracting? Dividing on the right is the same as doing what on the left? We're using your equation solving rules. So I'm going to argue the v would drop down like a domino, but I would times the t over, and then look up for 1 second. Don't write this next bit down. Look up, look up, look up, look up, look up. Jackson, I'm talking to you. Look up. Technically, it's this. Don't write that down. Do you mind? Can I put the d equals on that side? Because we're used to having the thing by itself on the left. Okay. That's another equation. Displacement is average velocity times time. You can memorize that if you want, or you can derive it. I might have given you this one on your formula sheet. You're going to find as the year goes further and we get better at this, I'm only going to give you the one main equation, and I'll say, oh, you can rewrite all these. It's a much better way to do it. And it saves paper. How would I get the t by itself? I want to come up with an equation that says t equals. This one is a bit tricky because where is the t? On the we don't have the skills to do math with a variable on the bottom. But wait a minute. Where is the t in this equation? On the, I'm looking for this letter T and rhymes with pop. Here it's on the top. And yes, it's on the right side. See the T? See the T? See the T? What's next to it? V. What's the V doing to the T? Adding, subtracting, multiplying, or dividing? So how would I move the V over to this side if I wanted to get the T by itself? Are you saying another equation, time, is displacement divided by average velocity? Yeah. You can memorize these three different equations, or you can learn, if you give me one, I can derive the other three. The second method is way better. And that's something you can also bring with you into your chemistry and math classes as well. You can dramatically cut down on your memorization by almost tenfold, by almost 10 times. Yeah. AV, average. I'm having to do things a little bit incorrectly because I'm trying to save paper. There's a symbol for average. It's this. Don't write this down. The problem is when I shrink it down, that and the vector symbol are almost impossible to distinguish. So what I tend to do is I'll put an A. Did I put an AV or an AVG as a subscript on your formula sheet? Yeah, that's average. I'm wearing my average shirt today. This says average nerd. Example 7. Motorist travels 350 kilometers during a 6-hour period. What was his average speed in A, kilometers per hour, and B, meters per second? I'm going to go A, B, there. Okay. I have an approach to problem solving that uses an acronym. And in fact, there's room for you to write it. Well, there isn't room for you to write it at the top of the page. We're going to write it, how about right here? I use an acronym called DFIC. Jot it down. You're going to hear me say this. Riley, I'm going to say to you, did you DFIC? And if you say no, I'm going to say, I'm not going to help you yet. The other acronym I use is DULP. DULP stands for draw a little picture. My Physics 12 students all know, when in doubt, DFIC and DULP. Before you ask me, try those first. So DULP is draw a little picture. DFIC is just a mnemonic acronym to give me steps to do. The D stands for list your data. The F stands for find a formula. The I stands for insert the numbers. And the C stands for calculate. Logan, the only time I'll get a little grumpy with a student is if a question is left totally blank, because that means they were too lazy to even list what they gave you. Let me show you what I mean. Logan, in part A, what are they asking me to find? Average what? Speed. Say it again, average. Speed. One more time, average. Speed. I could write out what is the average speed. That's way too much writing. So here's my DFIC approach. V equals question mark. I always write down what they're asking me to find, and I put a question mark next to it. You know what? I'll go back to black. Then what I do is I go back through the question, and I look for any numbers and physics words. You don't know any physics words yet, but you will eventually. And I list those. That 350, see it? What is that? Look at the units next to it and tell me what you think it is. Kenzie. That's a terrible 5. The next thing that I see is a 6. Look at the units next to it and tell me what it is. Time. Now, normally in physics, we do our physics with meters and seconds, but Logan did say in kilometers per hour, so I think I'm okay with that. Logan, I'm looking for an equation that has a V, a D, and a T in it. There is one. Now, right now, you're going, well, duh, it's right there. But halfway through the year, when we've got 80 or 90 of these at our disposal, this will be the strategy that we'll go with, okay? So I'm going to write down the equation. It's V equals D over T. Logan, what's the distance? Logan, what's the distance? And you can see now it becomes fairly plug and chug. It's about a 1-second setup, but I found by doing that, Evan, it dramatically cuts down on mistakes. So it's a good time investment. 350, and what's time, Logan? 350 divided by 6, good gosh, that's going to be 175 divided by 3. Does that work out evenly, Mr. Dueck? It does. There's going to be a 25, and there's going to... No, it doesn't work out evenly, does it? No, 350 divided by 6, Mr. Dueck. It's not working out evenly, is it? 58.3? 3? I'll go to 3 sig figs. 58.3. Looking at that number, if you were asked to make a prediction, was this person traveling on the freeway, on a highway, or on city streets? Subdivision streets or city streets? What's the speed limit in a subdivision? Typically 50 or less. City streets are often 60-ish. You know what? I'm thinking this is city streets, but not subdivision streets. Adam, what does B want me to find? It's time for a unit conversion. What am I going to do first? Write down what they, in this case, 58.3 kilometers. Slanty fractions are bad if I'm doing math, per hour. I need to get rid of kilometers. Where are kilometers right now? On the... So where is it going to be in the next fraction? On the... So kilometers there, meters there. Kilometers is 10 to the third or 1,000. Where is that going to go? How do you know? Where the metric prefix isn't. I'm going to write 10 to the third because that's less writing. Now, I need to get rid of hours. Does anybody remember how many seconds there are in an hour? So if I put hours on top, seconds down there, and you're thinking it's 3,600? What do you get? It's going to be times by 10 to the third. Oh, by the way, although I wrote 58.3, do you all still have this stored on your calculator? Let's use the more accurate value, the non-rounded off value. Times 10 to the 3 divided by 3,600. And I get 16.2 meters per second. Okay. Now I used my answer button. Yours, yeah.
Is it normal? It might be just like a little bit off.
Did you use the answer button or did you use 58.3? No, you didn't. Did you use your answer button or did you type 58.3? So of course you're off because I used my answer button. I used 58.333333333. If you have the previous value that you're using stored on your calculator, use your answer button. It's more accurate and it's less typing. That's a double win. And it's less room for error. Units, Adam? This conversion from kilometers per hour to meters per second and from meters per second to kilometers per hour, we're going to do a lot. It's about the only conversion that will do a lot. Well, I mean, time. Sometimes they'll go from hours to minutes to seconds because time. Let's come up with a shortcut for that later on today. How many of you have ever stood somewhere and had an echo? Okay. If you've ever wondered how far away whatever your voice is bouncing off of is, here, so I can figure it out. Speed of sound is 330 meters per second. That varies depending on altitude and temperature and humidity, but it's anywhere from 313 to 330 is a nice round number. Sheldon is shouting at the base of a steep mountain. If the mountain is 420 meters away, how long will it take before Sheldon hears his echo? What's this question asking me to find? In terms of the physics variables we've been looking at, what's it asking me to find? I think the distance is 420. I'm going to say that's a bad guess. Write down t equals question mark. Looking for me? Oh, you're just watching? Yeah. What's that 330? What are the units right next to it? What do I measure in meters per second? It's a speed or a velocity. Even if they hadn't given me that word there, by looking at the units, I can figure it out. This is one of the reasons I'm going to encourage you. It's really worth memorizing what units go with what. It's a speed. Our symbol for speed is a V without the vector sign, 330. What's that 420? What are the units right next to it? What do I measure? Ah, good. Distance. And I did a quick check. Meters per second, meters, my units all match up. I don't have one thing in hours and one thing in seconds, or one thing in meters and one thing in kilometers. If there was, I'd have to do a correction. Looking for an equation that has a T, a V, and a D in it. There is one. Sorry? Get the T by itself. How would I get the T by itself? Divide what? Let's use nouns and not pronouns. Divide the V over, okay? So I don't need to if I know this, if I have this equation on my formula sheet that contains the other three equations, I don't need to memorize them. They're all hidden in there. It's going to be D over V. So you're telling me it's going to be 420 divided by 330? Is that correct? What do you get? Oh, I typed that in wrong. You get 1.2727272727. By the way, you can see my calculator is rounding off, but I'm pretty sure it's 27 repeating all the way down, yes? Why must this be wrong? This is wrong, and there's a candy if anybody can spot it. Measurements are fine. Nope. That's what we just found out, but why is that the wrong answer? Why must that be the wrong answer? Units are fine. Think about how echoes work. Kenzie, what did you just do with your hand? What was that? We just found the time to get to the wall. What? Ah, I like this question. I like this question. I like this question. I like this question. Why would I say that? Did you hear me say that it was going to be on the test? Or are you just the kind of student that tends to notice when your teacher emphasizes certain things? Good, 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 good. So I'm going to take this, and I got 1.27 repeating. I'm going to use my answer button. I'm not going to round off, and I'm going to times that by 2 because it's got to go there and back. Or what I could have done at the beginning, Kenzie, is I could have said the actual distance is 840. Either method is fine, but that's how echoes work. And I get 2.55 if I round off properly. Seconds. Now, if you are ever somewhere where there is an echo, you can reverse this. If you time from when you yell, how long until you hear it, could you actually get the D by itself and figure out how far away? You'd have to divide by 2 though. But yeah. Something that if you're ever bored somewhere at a cliff and you're wondering How far away is what my voice is hitting? It's nerd physics, but it's kind of nice to be able to pull it out of your back pocket. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel? A, in kilometers, and B, in meters. Why is this question a bit yucky? Sorry, I promised a candy. Let me pause for a second here. And maybe this is too obvious, but why is example 9 yucky? Units don't match. So either I'm going to change the hours to seconds, or I'm going to change the meters per second to kilometers per hour. What's the first thing they're asking me to find? Part A. You know what? I think I'm going to change this to kilometers per hour because that's... by the way, if I change this to seconds, I'd find B first and then I'd convert. You know what? Let's do that, actually. That might be easier. Sure. So, are they asking me to find two things? Are you spotting a trend? I typically go like this. I go like this. Let's use my DFIC approach here. So, what are they asking me to find? I heard it here. So I'm going to write D equals question mark. I've written something down. I feel better. And by the way, the other reason I'm showing you this is by the end of the year, when you've got 80 or, well, when you've got that whole page to pick from, as soon as you see the D, you've just eliminated about 80% of the equations. Okay. What did we say we're going to do? We're going to convert the hours to seconds. Yes? So this is 2.5 hours. How do I convert that to seconds? You know what? I don't need to guess. I want hours to cancel. I want seconds left behind. Is it 3,600? Is 1 hour? So 2.5 hours is, I can do that in my head, it's going to be 7,200 plus 1,800, 8,000? No, 9,000? And that is seconds. And then what's that 18? Got to be a V because it's meters per second. I'm looking for an equation that has a D, a T, and a V in it. There is one. I think we just used it, did we not? Now you might be saying, Dueck, this is easy. There's only one equation. Yeah, but talk to me in January when you've got 70. You'll get there. We'll get there. I'm starting you off in the shallow end. So it's going to be 18 times 9,000. I can do that in my head. 10 times 9,000 is 90,000. 8 times 9,000 is 72,000. It's going to be 72,000 and 90,000. 162,000? Double check me. Yes? 3 zeros? Units? Meters per second will be velocity. This is why even just writing that helps you avoid that little mistake. Oh, meters. And this you will memorize what units go with what. And have you all spotted the shortcut or derived your own shortcut for going from meters to kilometers and vice versa? Yeah, Ben, how do I go from meters to kilometers? Don't look at him. He's not allowed to help you on a test. No? Okay, let's write down what they gave me. 162,000 meters. I want meters to cancel. I want kilometers. The 10 to the third goes down there. And some of you may have already noticed, because you may have developed this shortcut on your own, to go from meters to kilometers, you divide by 1,000. And if you can do that without writing anything down, I'm fine with that. So I went, oh, it's 162 kilometers. I think we're finished here. Almost finished here, Mr. Dueck. By the way, I'm going to be assigning homework, but your homework actually is to study for the test. This is due the class after the test. Let's finish here. True or false? An object can have a positive distance while having a displacement equaling 0. Don't blurt out an answer. We're going to vote. How high you hold your hand up is how sure you are of the answer. I'm positive. I'm pretty sure. I'm only voting because Mr. Dueck will make fun of me if I don't vote, and Mr. Dueck will make fun of you if you don't vote. The only thing that'll annoy me in my class is if you don't make a hypothesis. Even a bad hypothesis is a good learning opportunity. So again, true or false, an object can have a positive distance while having a displacement equaling 0. Who says true? 1, 2, 3, 4, 5. Riley goes peer pressure. 6, 7, 8, 9, 10. Who says false? Okay. Was that a hand up as well, Evan? Just adjusting hair number 93? Enjoy it while you got it. All right. Convince me. You can attack someone else's answer as being wrong or defend your answer as being right. Convince me. Yeah. Here's what I heard. If you go positive and make the displacement 0, that answers the question. Give me an example. I'm going to start. Oh, yeah, go ahead. Instead of somewhere, can we be more specific, please? I'm going to start a sentence. See if you can finish it off for me. I would absolutely take that as a perfectly valid proof. 2 steps forward, 2 steps back, 1 step east, 1 step west, whatever, something like that. Absolutely. No. It's a positive distance, but it's a 0 displacement, right? So, true. All right. Can you have a positive distance and a negative displacement? Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. Positive displacement, positive distance, and a negative displacement. Who says, true, Mr. Dueck? I think that's true. Absolutely true. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and a latecomer, 16. This one's a little more split. Who says false, Mr. Dueck? 1, 2. Okay. Oh, 3. Sorry, I missed that. Convince me.
Like 2 steps forward. And then
Hang on, let me write that down. 2 steps forward, comma.
And then 4 steps backwards. And you like a negative distance.
I got a that's not a negative distance.
Displacement.
Okay, your displacement would be what? -2, but what's your distance?
6.
Because distance, by definition, since it's a scalar, is going to be positive. Are you positive? You could have just said take 4 steps backwards, and that would have a negative displacement and positive distance. Yeah.
Do you mind going back to example 8 really quickly? I missed it.
I'll come back to that in a second, but we're not done here. Number 12. Antonio, I'll bring it up later. Don't fall behind trying to get caught up. So, 0 distance while having a positive displacement. Yeah, Savannah, we're going right to the tone. You'll be okay. 0 distance, positive displacement. True or false? An object can have a 0 distance and a positive displacement. Who says true? Ooh. Who says false? I can't think of a way that it could be true. Because if you have a positive displacement, you must have taken at least 1 step. One of my favorite comics is Foxtrot. The author, Bill Ammond, actually has his physics degree. While he was in college, he did a lot of doodling as well, and his friends said to him, you should get those published, they're kind of funny. So Foxtrot looks at a family, and the youngest boy, Jason, is the nerd boy that I can identify with. So here's Jason. He's playing football with his older brother, Peter. And he says this, okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards. Then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I hit you with the ball. Peter thinks about things for a while, and he says, won't I be right back where I started? Jason says, I can't throw very far. I have, on a sunny day, taken my kids into the backfield. We have run this play, and it is a displacement of 0. The physics here is correct. You do end up back where you started from. So what will Peter's displacement be? 0. What will the distance be? 40 plus 20 plus 25 plus 30 plus 30 plus 10 plus 15 plus 20 plus 50. I can do that in my head. 60, 85, 115, 145, 155,
Good afternoon,
100.
everybody. Excuse the interruption. Just a
Pause
reminder
for
for
1
grade.
second. What do you get? 210? Am I wrong? I might be off because I got interrupted by an announcement. 60, 85, 115, 145, 155, 170, and 240? Okay. You're right, it would be yards. Thank you. Candy for you. You have a unit review that I gave out last class, yes? That's your homework. Thanks for your patience. I didn't think the lesson would last quite this long, but I tried to keep it vague.